Hi everyone. So let's start with GATE DA course. So this is the first module of GATE DA course is probability and statistics, and the first concept in that is counting. So we will finish counting first, and we will put every video of counting in a playlist, so you can access them all in the same playlist. This is lecture 1, and we will discuss rule of sum and product in this session. So first, what is the motivation of counting? Why do we count? So we want to do ML, right? We want to do ML and AI, and we will have data sets of large quantity. We will handle large numbers of data. We will have large amounts of data. And one good example is let's say I have 1,000 entities of some kind, and I want to do some sort of pairing. Okay, so let's say I want to keep object A and object C together. So how many different ways of pairing are there? Walmart used this problem. Okay, so if you know about it, it is called associative learning. So back then, what happened is, in every grocery store, if you see in US, items were placed here and there, and generally in India we still have shops. We go to a shop and we ask for an object, I want let's say toothpaste, right? And they will bring it for you. You have to mention the brand and the toothpaste name. Walmart was the first store with what they did was they removed the shopkeeper concept and they made the store free, right? You just go in there and pick objects whatever you want, and they had large amount of profits. It's the #1 company in retail right now in world. And what they did was they did a beautiful thing, associative learning. They kept bread and butter together. Very easy concept, right? They just understood what are the things which people tend to buy together. Pen and pencil together, so all stationery items together. Nowadays you see it in every mall, but think about it, small problems. But where does counting fit in? Let's say I have 1,000 items. How many different pairings or triplets do I have? So that's a math problem now. So it's that's where we will need the concept of combination, permutations, and counting. So that's the motivation. In ML problems, generally counting all possible ways is what you will need in day-to-day life. So yeah, many times one needs to calculate the number of all possible outcomes for a series of events. You are doing some task and then some task and then some task. In how many possible ways I can accomplish my goal, right? So that's counting. For example, we know that in India we have 10-lettered PAN numbers. So in how many ways we can generate 10-lettered PAN numbers, such that the first 5 letters are capital alphabets, next 4 are digits, and the last one is again a capital letter. So this is a counting problem. And in most of the times what happens, counting might go astronomical. So astronomical numbers are huge. They so for example, if you want to see the distance between sun and earth, it will be astronomical, right? It's in 10 to the powers. So counting can go astronomical, and that's where ML will come in. So you have a large space, but you want to just go and hover over a small space, and ML will help you reducing the dimensions, reducing the data set, and so on. So the first concept in counting is the rule of sum. So if a sequence of tasks T1, T2 up to Tm can be done in W1, W2, Wm ways. Okay, so what do you want to do? We want to perform a task T1. Let's say I want to do laundry. Then I want to do some other task. I want to cook something. Then I want to do some other task. Okay, we are doing sequence of tasks one after the other. Okay, and T1 can be done in W1 ways, T2 can be done in W2 ways, T3 can be done in W3 ways. So what we want to do is the condition is that no task can be performed simultaneously. They are not dependent. So I should actually remove this. There is no connection between these tasks. Okay, let's say we will come to connection in the next slide, don't worry. So let's say there are 3 tasks, T1, T2, T3. They can be done in W1, W2, W3 ways, and no task can be performed simultaneously. then the number of ways you can do one of these tasks is w1 plus w2 plus up to wn. So you just sum all the possible ways. So for example, in how many ways, so it's like OR. In logic we discuss OR and AND, right? It's like OR. So yeah, T1 can be done in W1 ways, T2 can be done in W2 ways, then T1 or T2 can be done in W1 plus W2 ways. So this is the like rule of sum in counting. See, why are we learning all this? Right now you straight away you don't see a use case, right? But the problem that will come will involve all these concepts at once. Rule of sum, product, permutation, combination, everything will be applied in one single problem. So you need to learn every bit and piece. Okay. So we can write it this way as well. So consider like two tasks A and B. So right now we are doing it in set notation. Okay, this is set A, this is my task A, and this is set B, this is my task B, and they are disjoint. Okay, this is very important. They are disjoint. They don't have anything in common, and A has W1 ways to do it, and B has W2 ways. So for example 4 and 3, and they are disjoint. Then mathematically, like in how many ways can I do A or B? I can just take union of these two sets, right? So what is the cardinality of union of A and B? Like you will have 4 plus 3, which is 7 elements. So that's just the rule of sum, very easy. So for like just see this example. There are 4 types of cookies. So like just see the problem once. There are 4 types of cookies and 3 types of cakes available in the store. In how many ways can we select any one item to eat? Okay, disjoint problems. Cakes and cookies are disjoint, and also I just want to select any one item to eat. Okay, so I'm not doing tasks one after the other, I'm just selecting one item. So I can either select a cookie or I can select a cake, right? How many different choices do I have? 7 choices, right? 4 plus 3. Sorry. So next is rule of product. Now a sequence of tasks T1 and T1 up to Tm can be done in like the same W1 up to Wm ways respectively, and here the condition is different. The tasks are not disjoint. The condition is that every task arrives after the occurrence of the previous task. Now we have that sequence. Okay, so we are doing T1. So you can always put rule of product in a DAG like this, like it's an acyclic graph. So I'll tell you how it works. So let's say I am at a start point. I want to do first task T1. Then I want to do, let's say, task T2, and I want to do task T3, and here is my ending point. Basically you just want to calculate in how many ways can you reach the ending point, right? Now T1 can be done in W1 ways, T2 can be done in W2 ways, T3 can be done in W3 ways. Okay, you can perform T1 in W1 different ways. With an example it will be more clear. I will show you in the next slide. But the number of ways in which you can reach the ending point from starting point will be W1 into W2 into W3. So whenever you can put the tasks in a sequence, you apply the rule of product. Okay. So again, mathematically we are just multiplying the cardinalities of all these sets. So like consider this example. There are 4 types of cakes, like cookies, and 3 types of cakes again. In how many ways can I select one cookie and one cake? So now I want to select one cake and one cookie. So here are my cookies. Let's say C1, C2, C3, C4. And cake, let's say I'm saying D, D1, D2 and D3. Okay, these are my 4 cookies and these are my 3 cakes. What I want to do, I want to select one cookie, select one cookie. Again in logic what we are doing, in logic we are doing an AND, select one cookie and one cake. Here we don't have an OR, we have an AND. So again rule of product, whenever we have AND, rule of product, select one cookie and then select one cake. And this is my ending. So in how many ways can I reach the end? First select one cookie, there are 4 ways. Then select a cake, there are 3 ways. So there are 12 ways in which I can select one cookie and one cake. What are those 12 ways? I can select C1 and D1, first cookie and first cake. Or I can select C1 and D2, C1 and D3, and so on. Last one will be C4 and D3. So there are 12 ways. Okay, whenever you have AND, rule of product. Now let's try to solve this problem. So I'll explain the problem first. A boy lives in a town X and wants to go to school at Z point. Okay, so X is his home and Z is the school. From his home X, he has to first reach, let's say there is a bus stop or something, there is some stop which is Y. So from X he has to reach Y, and then from Y to Z. And he may go from X to Y by either 3 bus routes or 2 train routes. And from Y to Z he has 4 bus routes and 5 train routes to Z. So in how many ways can he go from X to Z? So what we want to do here, we have a boy at X and there is a station Y and there is a station Z. We want to go from X to Z. Okay, from X to Y there are 3 bus routes and 2 train routes. From Y to Z there are 4 bus routes and there are 5 train routes. So in how many ways can I reach from X to Z? That's what the question is. Okay, so think about it. Consider this task as one. In how many ways can I reach from X to Y? So either I will take a bus or a train, or right, rule of sum. So I will take a bus or a train. How many ways do I have? 5 ways. To reach from X to Y, I have 5 ways. I can take either a train or a bus, any 5 options. Okay, similarly from Y to Z I have 4 plus 5, 9 options, 4 buses and 5 train, or again. Okay, now it is a sequence. You have 2 tasks, right? Do X to Y and Y to Z, and right. So whenever you have and, rule of product, so you have 45 ways. So basically what you are doing, like, what are these 45 ways? Take the first bus and the first bus here, take the first bus and the second bus here, similarly like first bus and the 5th train, and so on. The last option will be the second train and the 5th train. So there are 45 different options in which you can achieve this. Here we are applying both rule of sum and product. Always remember, or we are applying rule of sum and we are applying rule of product. Okay, so now it's an interesting problem. It will apply everything we have learned so far. Firstly, let's try to do it like normally. How many divisors are there of 1000? Okay, so we know that 1 divides every whole number. 1 is a divisor of 1000. If you like keep going on, like counting like this will be very difficult, right? Again, like counting, it is a problem of counting. We have like 1000 numbers between 1 and 1000. How many of them actually divide 1000? So 1, 2, 4 and so on up to 1000. Okay, so counting like this might take a lot of time, right? But we can actually very intelligently apply the rule of sum and product. So I will explain the formula first and then we will solve this problem. Okay, so like first try to understand this formula and then we will apply it on 1000. So whenever you want to count the number of divisors of any number, okay, there is a standard way. So let's solve it using this example only. So try to always try to do the prime factorization of 1000. What is prime factorization? Writing a number in powers of its prime factors. Writing the number in powers of its prime factors. So okay, what is 1000? If you do it like you can do it like this also, but it's very easy. Like 1000 is easy. 1000 is actually 8 times 125. So it's 2 to the power 3 into 5 to the power 3. So again, like if you love math, this will be easier, right? So yeah, this is the prime factorization of 1000. Otherwise you can do it this way. This is how we learned it, right? You divide it by 2. You keep dividing it by prime numbers and you'll get the prime factorization. Okay, let me do it for you. Just this once. So this is 1000. 2 divides it. So just go with the smallest prime number and see if it divides the number. So 2 again divides 500. So it will be 250. 2 divides 250. So again we will divide it by 2, 125. Now 2 is not dividing 125. So go to the next prime number, 3. 3 is also not dividing 125. Go to the next prime number, 5. 5 divides it. So 5. Then we will have 25. Again for 25 the smallest prime number will be 5. Again 5. 5, 1. So it is 2 cube into 5 cube. Okay, this is the prime factorization of 1000. So think about it. What is 1000? Okay, why am I doing all this? So there is a logic. 1000 is 2 cube into 5 cube, and any factor of 1000 will be what? It will divide 1000. So what is divisor? It will divide 1000. So this is 1000, 2 cube into 5 cube. Can 7 divide it? 7 cannot divide it. Why? Because 7 is not in the prime factors of 1000. The only numbers which can divide 1000 must have these prime factors, 2 and 5 only. And also you cannot have 4 2's, 2 to the power 4. This cannot divide 1000 because you only have 3 2's in 1000. So this is the capability of the number. Think of it this way: 1000 has 3 2's and 5 3's. So any number which is which has fewer than 3 2's and fewer than 3 5's can divide it. For example, a number like 2 square into 5 ki power 1. This can divide 1000. This will always divide 1000, because when you divide it, you will have 2, and here you will have 5 square, right? You cannot have in the denominator, you cannot have 2 to the power 4 or 5 to the power 4. So any number which can be represented in this form, 2 to the power something into 5 to the power something, will be a divisor of 1000. Now this something we know has to be between 0 and 3, and this something also has to be between 0 and 3, right? So if I just create a set like this, so just create a set for every prime number. This is a set for 2, power of 2. This is the set of power of 5. 2 to the power 0, 2 to the power 1, 2 to the power 2, 2 to the power 3, 5 to the power 0, 5 to the power 1, 5 to the power 2, 5 to the power 3.
Excellent.
Yeah. Take any number from here, take any number from here, and multiply them. That will be a divisor of 1000, right? Simple, right? So take 2 to the power 1 from here, 5 to the power 2 from here, multiply them. So 2 to the power 1 into 5 to the power 2 will be a divisor of 1000. So again, do the prime factorization, just keep them empty spaces, and any power smaller or less than or equal to this will be a factor. So how many options do I have for 2? 3 plus 1, actually, not 3, because 2 to the power 0 is also an option. 0, 1, 2, 3. So we have 4 options for 2 and we have 4 options for 5. Again, why rule of product? I have to take a power of 2 and I have to take a power of 5, and rule of product. So I have 4 options here and I have 4 options here. So you have 16 divisors for 1000, right? So you can now actually calculate the number of divisors for any number from whatever we have learned. Cool. So this is the formula. Again, very easy to derive, whatever I did before. Let's say the prime factorization of a number n is p1 to the power e1. Sorry, here it should be p2 to the power e2, pk to the power ek, where pi are distinct prime numbers. This is how prime factorization looks like: prime number to the power something, prime number to the power something, and so on. Then the number of different divisors of n will be e1 plus 1 into e2 plus 1 up to ek plus 1. Why? Again, same logic. This is first prime number, second prime number, and kth prime number. Here we have e1 plus 1 options. How? p1 to the power 0, p1 to the power 1 up to p1 to the power e1 plus e1. Okay, so these are all the options I have for the first prime number from 0 to e1. Again, for p2 I have how many options? e2 plus 1. How? I can take p2 to the power 0, p2 to the power 1 all the way up to p2 to the power e2. And for kth prime number I have pk to the power 0 up to pk to the power ek. So simple, take one element from each of these and we have an AND. Take an element from here and here and here and so on. So here I have e1 plus 1 options. Here I have e2 plus 1 options all the way up to ek plus 1 options. Okay, so it is a standard problem for rule of product. Cool. Now a slightly more interesting problem comes up. What is the sum of all divisors? Sum of all the numbers which divide, let's say, 1000. Okay. So think about it. We can actually do it from whatever we have learned so far, okay? So this is the formula, very big formula, but we will derive it, okay? It will be very simple. So let's do it on an example, then we will derive it. So again, let's take 1000. How did we calculate the number of divisors? Like we know that 1000 is what? 2 cube into 5 cube. We have to take a number from here and a number from here. So we have options for 2 to the power 0, 2 to the power 1, 2 to the power 2, 2 to the power 3, 5 to the power 0, 5 to the power 1, 5 to the power 2, 5 to the power 3. We know that there are 16 divisors. What are they? 2 to the power 0, 5 to the power 0. We take one number from here, one number from here, right? That's what we are doing. And what is the other number? 2 to the power 1, 2 to the power 0, 5 to the power 1. We can do this like 2 to the power 0, 5 to the power 1, and so on. The last number will be 2 cube into 5 cube. And we have to calculate the sum of all of these. Sum of all possible such divisors. So, yeah. So think about it. What we can do is we can simplify this equation. This sum is nothing but just add all these numbers. It will be very, very like beautiful. Like see 2 to the power 0 plus 2 to the power 1. Just sum all these numbers. 2 cube into, so we have one big bracket, sum of all these numbers multiplied by sum of all these numbers. 5 to the power 0, 5 to the power 1 plus 5 to the power 3. Why? Just expand the bracket, you will see. If you expand the bracket, you will have 2 to the power 0 into 5 to the power 0 plus this into this plus this into this plus this into this. This is actually the sum of all divisors, right? We said that these are all the divisors. Take one number from here, one number from here, one number from here, right? So even if you have more prime numbers, just make big brackets, sum of all the numbers in one of the brackets. And when you expand this entire thing, you will have sum of all the divisors. So yeah, this expanded is actually equal to sum of all the divisors. Sorry. Yeah, and this is what we wanted, right? So yeah, like now, but how to calculate the formula? Very simple. These are all geometric progressions. These are all geometric progressions. They start from 2 to the power 0 or any prime number to the power 0 and they go up to some prime number to the power k. Very easy. So sum of GP is what? So the sum of GP is A r to the power n minus 1 upon r minus 1. Right? So how? Like if you want to calculate the sum of A plus A into R plus AR square and so on up to n terms. This is the sum of GP. Very easy. Like we know this from like our childhood. So like yeah, just apply the formula, and that's how we are here deriving this formula. So if you have a prime number like this, if you have any number and prime factorization is this, you have even options in P1. So what will happen for the first prime number? For the first prime number P1, you will go from P1 to the power 0 all the way up to P1 to the power E1. So let's first calculate the sum of this GP only, okay? What is the sum of this GP? P1 to the power 0 plus P2 to the power, P1 to the power 1 plus P1 to the power 2 up to P1 to the power E1. So it is A. A is what? The first element. First element is always P1 to the power 0 or any number. It will always be 1 because it will be prime number to the power 0. A is first element A. R is what? The number which we are multiplying every time, which is P1 here. Okay. So A r to the power n. How many elements do I have? E1 plus 1. I have E1 plus 1 elements. So A r to the power n minus 1 upon r minus 1. So this is the sum of the first bracket, which is written here. Similarly, the sum of the second bracket will be this, and so on. You just multiply all these, you'll get the sum of all divisors. So if you do it for 1000, it is like simple now. So let's apply it for 2. a is 1, so r to the power n, r is 2 here, 2 to the power 4 minus 1 upon r minus 1, and multiplied by for 5, r to the power n is also 4 here, we have 4 elements, minus 1 upon r minus 1. You just calculate this, it will come out to be 2340. Okay, so I hope you got it. Okay, we are somehow applying rule of sum product here in all these cases, and these are standard problems. You can get these problems even in the aptitude section. Okay, so like counting is one subject which has common like thing with aptitude section as well. You will get these questions both in math and aptitude section for GATE, CS and DA both. Cool, thanks a lot. So this was the first session. See you tomorrow.